Hi, in the previous video we took a look at this Miniware DT71 Tweezer LCR meter. Stay on, you bastard. There we go. No. No. Why isn't it staying on? There we go. I was going to say the TLDR from it, which is too long, didn't read, from the previous video is that it's not very accurate. It's got limited resolution. It's got limited ranges. There's accuracy issues between manual ranging and auto ranging modes. For some reason, it uses non-standard test frequencies. You can't use it while it's charging with this lead. And of course, yeah, most complaints about this were like the charging system, that you had to disconnect it and you had to physically charge it separately, and the tilt head detection was, which by the way, you can actually disable the tilt head detection in the configuration file, as Miniware actually pointed out, so that's good. If you're always right-handed and you just don't want it to change, then you can fix that, so that's good. Its LED testing is limited, couldn't do reverse polarity, and basically the secondary parameter measurements like the ESR of a capacitor and stuff like that basically didn't work. So there was a lot wrong with this, but it's $70, but as a lot of people pointed out, $59, I believe you can get it for, and not including shipping though, at Seed Studios. But the saving grace for this thing was that, well, A, it's cheap, and B, it was the gorgeous probes on it. And a lot of people said that they should actually sell just the probes for this thing. The batteries are in here, apparently there's a battery in there and in there. And and charging circuitry in here and a little charging lead. Apparently, a lot of people said that they would buy just the tweezers if it came with like a short lead that hooked onto your LCR meter or something like that. So I think they should definitely do that, because the probes are actually gorgeous. Anyway, a lot of people wanted to see a teardown of this thing, and the reason I didn't do a teardown last time is because I wanted to get the review video, because in the manual it specifically tells you if you open this thing, you can't get it back together. So obviously, like, this is all like ultrasonically welded together or something like that. But apparently, this will be a destructive teardown. But anyway, I do actually have another I think it's just under $100. You can get it from Mouser. It's a Global Specialties LCR meter. I've got one of those on the way. I'm going to do a review of that. And then somebody else pointed out that there's an LCR research one as well. Coincidentally, another Canadian one, as well as these Smart Tweezers. Smart Tweezers very expensive. I've got the old model. They got a new model, but it's many hundreds of dollars. And LCR Research in Canada as well. They actually make ones too, which actually come with a NIST calibration certificate. Very nice for the price, but they're very expensive as well. But they have a lower end model for 169 Yankee bucks that comes with a NIST certificate and everything. So that might be worth checking it out as well. But anyway, I've got another one on order. But anyway, this video, let's do a teardown, shall we? And after we get the probes off, you can see in there that they're just the contacts inside there. All of these LCR tweezers, they all pretty much either come with, or you can get replaceable probe tips, because sooner or later, after a couple of years heavy use, you're going to be wearing down those nice sharp tips. Take these screws out here and you can see there's a magnet in there. You can see the magnet in there. That's the attractive one, apparently, according to the 3D model. And then there's another magnet in. Do these come out? How do you... I don't know. I've got the screws off. Can I... I might have to break it apart. I don't know. But you can see another magnet down in there. That's what repels them. So that's what gives it a really nice, gorgeous feel. And I forgot to mention that it looks like these are actually just 2-wire probes. Some of the more expensive ones, I believe, are like 4-wire, so they'll have like a sense wire coming up there. So it just eliminates the leads in there from the test. But, you can, like, 2 wires okay for, something cheap and simple like this. Well, I don't know what those screws do either side, because I take them out and I can't get this apart anyway. So yeah, might just have to do a wishing bone thing. I don't really want to. Geez, I'd love to, like, I don't know. All right, screw it. Here it goes. Come on. No, is it still going to pull out? No. Damn. Oh, I don't want to. Like, oh, there we go. There's something. Okay, there's a trick. There was a trick to it. Okay, I think I had to get my screwdriver in there, did I? Or something? Like a little spudger in there. And pry that out. Oops. Well, this is interesting. It's got some sort of like... that's a flat flex. Okay, yep, I can see. Yeah, I can see the traces on it now. You don't often see like a gloss black flat flex like that. But yeah, I can see traces in there now. So I believe that the batteries are in here. So yeah, looks like I can probably maybe pry that car. No, it's either glued or something in there. But anyway, we've got our magnets. So that's how they're connecting into the charging circuitry using these little flat flexes. Yeah, they weren't kidding that this thing wouldn't come apart. That's why they put it in the manual. They say, yeah, don't try and take it apart because you won't get it back together. And there we have it, 3.7 volts, 0.185 watt hours. Thank you very much. They're going to have one of these, 50 milliamp hours in each side there. So that's the total capacity. As I mentioned in the review video, I believe 20 hours runtime or something. So with a 2-hour recharge. Yep, 2 identical batteries. But yeah, that was glued in. That wasn't coming out easily. Like it was glued in at the ends here. And yeah, you just had to pry it all out. And there you go. The contact is just an extension, an exposed, unsolder masked extension of the flat flex there. So that's actually rather nicely implemented. As I said, I'm very impressed by the probe design on this thing. So they put all their effort into the probes, unfortunately, and the rest of the firmware and other stuff, you know, and the charging system, it leaves a bit to be desired, which is a shame because, yeah, it really is a sexy bit of kit, these probes. So, yep, there's our 2 magnets that we got out of the arms there. And watch this. There we go. They're the neodymium magnets. Oh, either side there. So they're the ones that caught it. They're the attractive ones that sort of... oh, yep, there we go. Oh, yeah. Yeah, look, I can actually rock that now. Woo! Nice. So you can see it. Even though I go like that, it flicks it. So there you go. You can see how that just draws those probes back together. So these two here, pushing apart, counteract the force of these two here. And it's just, it really is gorgeous. Yeah, if you just had these ones on their own, it'd be like, it snaps. It snaps back. But because you got these two in here, which then when you push it in, it doesn't just go, you know, it doesn't snap like that. It's just, they're just gorgeously balanced out. And wow, you know, hats off to the mechanical engineer at E-Design who came up with that, because that is just great. Okay, so these little aluminium side plates, they're held on there with some double-sided tape. Nothing wrong with that, I guess. And, oh, there you go. I can actually get that apart. I actually tried to force it from the end here first. And then I realised that the side panels will just come off. And it's just clipped together. So it is possible to get this apart without too much damage, although I've just... oh, no. They're shield. They're shield wires, are they? Look, there's 2 exposed wires either side there. That, I presume to shield, use these as shields, although were they, I have to rewatch the footage. Were they actually under the tape? So, but obviously that's deliberate. That is deliberate to shield those sides, I'm sure. That's got to be... It's got to be the reason, but was the tape covering it? That'd be a fail if, like, the designers went, oh, yeah, let's be clever and we can use these as metal shield side plates. And then in production, somebody just went, oh, we need to stick them on. Let's just put tape and then they cover it and insulate it. That'd be hilarious. Sure enough, you get those clips off and this bad boy is just going to come apart. Oh, there we go. We're in. Ooh, got some black gunk there. What are they doing that for? Is that, you wouldn't need that for insulation. There's nothing on the other side of that. There's no nickel screening or anything like that. So, yeah, oh, look at that. We can get the whole lot out. Just comes out as one assembly. There it is. Sweet. That's actually 3-board construction. It looks like there's something on the back of the LCD there. Yep, there's a flex. There's a flex. There you go. Oh, wow, look at that. Yep, that's how they get the small form factor. Ah, there we go, that flat flex. I thought it was like embedded in the inner layer of the PCB, but it's not. That's actually, I thought that was gunk. That's actually the part of the flat flex and then just going onto the board there. So is that, do they solder that on, or is it conductive glue? I think they might. No, that's the, no, they're the solder joints. Okay, so they're the solder joints for the 4-pin TRS jack there. So we've got our 4 pins, and then our flat flex is part of that, because they obviously couldn't fit all that stuff on the main board. I mean, as I said in the review video, like, why have they gone so small with this head? I mean, it just didn't make sense. And those wires there and there, yep, very deliberately soldered onto the ground terminal of the TRS jack. There you go. So that was very deliberate outer case shielding. But if shielding was important, like, you would use like a, I don't know, like a die-cast alloy head or something, maybe? Like die-cast like 2-part clamshell head, perhaps? And there's your touch button. It's just a metal mesh like that, just bent over. So yeah, it's like just a capacitive sense thing. So then there's got to be, yeah, there we go. A castellated edge. Well, it's not castellated, it's a gold plated edge. Castellation would be the holes in the side. But yep, they've just gone, yeah, we want gold edge plating on just that little bit of the board there. Thank you very much. The PCB manufacturing house will say, yep, we can do that. That's a separate process. No worries, just cost you a bit extra. Hi, yes, I'm back in the old lab / new lab, which I'm going to be moving into over the coming weeks. And I have moved over my soldering bench, which includes my Tegano microscope, which we're using now. And it includes my Mantis, my soldering irons, and my PC capture bench and everything else. In fact, I can show you. Hang on. Here we go. There we go. There it is. Hang on. Can I go full screen? Can I go full webcam? There we go. So it's, yep, I've moved over precisely one bench so far. There you go. And I'm getting stuff set up. And, oh, sorry, you probably can't hear me. I'm way away from the mic. I'm, yep, starting to set up a few things anyway. So yes, this will be permanently set up properly soon, and so the acoustics are going to suck until then. I'm going to do all the proper cabling, the proper acoustics. I'm going to set up everything properly, and it's going to be great. But until then, we're going to have to make do. So I just moved all the stuff in yesterday, and I just cobbled together, like there's just cables going everywhere to try and get this thing working. Anyway, let's zoom in with our Tegano. Even my remote controller's not like I normally have it on the side of the bench here, and if I rock the bench, the camera's going to wobble because it's sitting on top of my Tegano. Ah, it's, you know, feels good to be back. All right, let's go. And yes, the lighting's going to suck too because I know it's dark in this corner at the moment. Anyway, what do we got down there? We've got a CPO 1017. Ah, no, that's a CPC 1017. There you go, that's an Ixus OptoMOS relay, so PhotoMOS relay. There you go. Yeah, I need better, like a monitor up the top so I can just like see, like, so when I've got a camera set up, I can just, yeah. All right, so we've got another, is that a discrete tranny down there? NP2300. Yep, MOSFET. So we've got a relay switching and a MOSFET there. Oh, there's the LCD part number for those playing along at home. So, yeah, I don't know. Anyone want to reverse engineer that? There's 4 traces. There's 1 ground plus 3 signal coming in on the right-hand side there. And obviously, they just connect through to the pins on the TRS jack there. So, they're just soldering those directly on. That's the bottom side, version 2.31. 402 there, not sure. I'm presuming that's like just a little 6-pin op-amp, something like that. And NBT 83, I don't know, you'd have to know your surface mount part numbers, but a couple of protection diodes there, I'd say, and a couple of resistors. So that's interesting that that's basically in parallel with the pins on the TRS jack. Okay, let's see what these are. Yes, you can see noise on the image, like grain noise. That's due to the lack of light here in this corner. I'm just using the Tegano number. Anyway, what's an A3JK? A3JK, I hate SMD part numbers. Anyway, curiously, there's 2 of them, and they're just like they're just connected, I presume, through to a couple of pins on the TRS jack. So that'd be connected through to the probes, like basically straight through to the probe. Sorry if my head's too close to the camera. This is scary. All right, I'm not getting anything for the code, for the A3JK code there. Well, yeah, not with the first Google anyway. I've got a crystal over there, and it is just a crystal. It is not a crystal oscillator because that's one big ass pad on the end like that. So maybe there's some sort of like, instrumentation amp, maybe programmable gain, one of those front end type chips perhaps, or just maybe a mux. Are they just like a mux and they're just doing everything in the micro, which is going to be under there. So we're going to have to desolder a couple of things here. Well, we're going to have to desolder this entire top board to see what the micro is. Bloody soldering irons aren't even plugged in yet. Damn it. Okay, I've got hardly any tools here at all. So all I've got is a big ass tip and pair of tweezers, and that's about it. So I'm not sure if it's going to be easier to just cut those off, because I'm not going to reuse this. Okay, I do actually have a pair of side cutters. I did try and force it apart. That was a real mistake. So I'm going to... There we go. Yeah, I think I did kill a part. So... completely butchered it. Yeah, I think there was a SOT23 something or other in there. Oops. Yeah, sorry. So, I don't know, its remains are probably down in there somewhere. This is what happens when you've got like just like a pair of side cutters and a soldering iron and that's it. No sucker in sight. Oh, no, there it is. 65ZY, whatever that is. So here we go, we have a PCB, we've got 2 like amps, something like that, amps or switches, and on the other side, ta-da, we've got an ST, no surprises whatsoever. It's a L432. They got so many bloody variants, I have no idea what that is. And there you have it, it's an ultra low power ARM Cortex M4. 100 dry stone MIPS, 256K flash, 64K of SRAM. What luxury. Wow. There you go. And it's got rich analog peripherals, none of that poor rubbish. Independent supply. That's interesting. 112-bit ADC, 5 meg samples per second. Wow, that's screaming. Up to 16 bits with hardware oversampling. Wow. 2 12-bit DAC outputs. Obviously, they're using those. So yeah, so maybe, like, is it just direct output and then they're just muxing, those chips are just muxing those? Because if we go back to the videotape, yeah, there's nothing else on there. There's the micro. I don't know which pins are the DACs. You could look that up, but you know, we couldn't be bothered really. Is that one going? Oh, no. Okay, there's one going over to the board up there, and boom, that's come in. Is that almost coming directly in? It's coming under from the socket there, so they're reading that back. It's under the chip. It's under there. Don't know, but yeah, there's not a lot to it, is there? Anyway, we do have a little bit more on the bottom of this board. Got another jobby. What's that? Don't know what that is. Is that like a protection? Is that just like... I don't think that's an active part. I think that could just be protection. Anyway, we did have another transistor on the top. And there's our edge, of course. There you go. How they've just plated that on the side there. That's our edge contact for our vias there for a bit of reinforcement. So yeah, there's not much in it. Assuming that's like some sort of protection device maybe. Then I'm going to say that it's not quite direct, it's almost direct DAC output from, are they using both DACs? Are they driving both? And then, I don't know, that one's either a mux or an amp or one of those, front end jobbies or something. I don't see like it. I don't think it's like an I2C interface. Like it's not a serial interface or anything like that. Anyway, so these are what these would be range resistors and stuff. I would presume you'd need some of those. But yeah, there's not much in it, is there? I mean, geez, that's, you know, it's a little bit over here, but that's just like some relay and MOSFET switching, and maybe an amp, that little 6-pin SOT jobby, and it's about all she wrote. Wow. So you can obviously tell why this thing is A, cheap, and B, its performance is not that great. It leaves a bit to be desired, is because it's just like, you know, there's not a lot of hardware, and there's no, you know, really precision hardware in here or something. There might be, but you know, the spec is loosey-goosey. What is it, over 1%? Whereas some of the top, better quality ones, like, you know, twice the price, are like double, triple, even, or, you know, you buy a $300 one, it's like 5 times the accuracy of these things. So much more, they'd have much more precision components. Don't remember if I did I think I did a teardown of the old Smart Tweezers one, didn't I? I think I did. Anyway, let's have a look at our OLED. Let's rub my fingerprints off. Oh, that didn't do a good job, did it? Now, if you get this puppy in the right light, speaking of light, I do actually have another light, but that's not gonna, oh, there we go. I can see, oh, you can see the lines, look at that. You can see the traces in there, each column. Nice. And then you can see the rows over there as well. There you go. Rows and, yeah, oh yeah, look at that. So you can see the ridiculously fine pitch on those traces there. So they're our rows, they're our row connections, and these are our common connections. You see them all in there? Wow, it's hard to get the right light, of course. It's all about getting the light, but wow, you can really see that. So that is an OLED display. Very grainy, but you can see it. And that's the maximum 40 times optical zoom on my Tegano. Okay, I've amped the brightness up on the only light I have in here. You can almost see like the 3D nature of them, of the elements in there. That's pretty groovy, huh? Yeah, look, you can almost see, look, almost see the connections. You can see the connections on the top. And of course, there's a chip on glass, COG it's called. So that's the glass substrate, and that is one big die. That's one big silicon die. None of that bond wire rubbish, and that's just flipped over and connected directly on the glass, and then all of the rows and column drivers, looks like all the rows go up here, connected on this end of the chip. This side's the interface, all your interface connections coming over, and then all down around here, that's all your column drivers. So what's that? I think it's 96 by 12 or something, isn't it? So, yep, it's got to have like, you know, 130 pins or something in it maybe. So there you have it. That's it. Sorry about the poor image and audio quality and setup. Yes, I could eventually put the green screen behind here, although it'd have to be a fair way back because it's an Elgato green screen. It's like 2 meters wide or something, but I can actually put it at the back there and it could go up. Oh, but then I'd need a gap between my benches to actually do that. I might have to put a gap between. Oh, but then I couldn't have the continuous roll of ESD. There's so many things in like setting up a lab specifically to do the kind of stuff. I have that huge variety of stuff that I do. So anyway, yep, that's it. If you like the video, please give it a big thumbs up. As always, comment down below and over on the EEVblog forum, and you can actually follow supporters have already seen like discussions about moving into the new lab and things like that, including like, you know, there's even financial stuff, but you can also see those over on my library channel as well, even if you're not a supporter. So there you go. So that's it. I'm out of here. Geez, this really looks big, doesn't it? I'm just looking at there. There's my huge nose. Look at that. And yeah, this looks really deep. It's not. It's 50 square meters, half the size of my current lab, but I'm going to save $40,000 a year. Beauty. Catch you next time.